Okay, this time, going to do a statistics question. This actually comes from an AS paper, Edexcel past paper, but there's no reason something like this couldn't come up in the A level. So whether you're year 12 or year 13, this probability question is sort of valid, and it's something that can come up. So what's going on here is there's two bags, and they each contain different coloured balls, and we are sending, first of all, one ball over from bag A and putting it into bag B. And then we're reversing, we're taking one from bag B, putting it back into bag A, and we're being asked, well, it says the probability that bag A now contains an equal number is P. It says given that P is greater than 0, essentially find P and find N, right? So really what it's wanting us to do is sort of look at the possibilities. When is there an actual probability, right? Probability greater than 0, that bag A would end up with the same number of each colour. So I'll show you what I mean. First of all, I'm just going to draw it out just to refer to later on. This is going to be bag A, and it's going to be bag B. And we've got 4 reds, 3 yellows, and N greens. So one of the reasons this question is quite tough, I think, is that initially you might think a tree diagram is definitely going to help me here. It turns out a tree diagram is not really too helpful for a couple of reasons. So firstly, the fact that what we're interested in the end is what kind of state bag A is in. Do we have the same number for each colour in bag A? So if you have a tree diagram just like this, it's like red, yellow, green, whatever. You have a lot of outcomes. And say you select this path here, which goes red and then green. If you're being asked what's the probability of selecting 2 balls of the same colour or a red and a green, it's quite easy to just go along the branches and choose the applicable branches, right? But if you're saying what's the probability that bag A contains the same of each colour, it's not clear which of the 9 final outcomes actually corresponds to that scenario, and you have to go through a lot of sort of calculation, and this is all trial and error. It's quite a lot of work to go through. So we're going to do it without using a tree diagram, so we don't have to just go through all 9 of those outcomes case by case and do a lot of sort of just counting and checking what's going on. It's going to be a bit quicker. I'm going to label the first swap with a 1, second swap with a 2. And we're just going to focus on what's going on inside bag A. The reason I'm going to focus on bag A is because the question is asking what's the probability that bag A contains an equal number at the end of this process. Okay. There are red, yellow, and green. And I'm going to go initially, how many of each are there? Then I'm going to go after the first swap, how many are there? And then after the second swap. Okay, so initially inside bag A, 4, 3, N. What happens with each swap is we either lose a ball from bag A or we gain a ball from bag A. So one of these numbers will change by 1. Right, so for example, my first swap, 1 over here from A into B, I could be losing a red ball, which means instead of having 4, 3, and N, then I'll be 3, 3, and N. So notice how the other 2 numbers did not change. The second swap goes from bag B into bag A. So bag A is actually going to gain just one of these colours. So this is losing a red. Let's say it gains a green. Right, so that means the number of greens would go up from N to N plus 1. The other 2 numbers would sort of stay the same. Right, so these are this is how we're going to draw it out. Now we're interested in scenarios where we end up with the same of every single number. And the thing about being P greater than 0, so what it's saying is, like, for example, if N was, I was going to make it up, 100. Hopefully we can see there's 0% chance that we end up with the same number of every colour. We've got far too many green balls in this bag. I'm only changing each number by 1, and I'm doing that twice, right? So at most, I'm changing everything by 2. I can't get this 100 down to like 3 and 4. Even if I lost a green ball every time, right? I still end up with far too many for it to be the same numbers. So we're going to focus on those values then where there is actually a non-zero probability of ending up with all the same numbers. Maybe they're all 5, maybe all 4. At this stage, you might be able to see already what to do and which possibilities are kind of possible. So you don't have to draw this whole thing out. This is for me to show you. One possibility is we're actually going to end up with 4 of every single colour. Now this is possible. So initially what can happen? Well, in this case, you would not want to lose a red ball initially from bag A into bag B, because then you would end up with, well, 3 reds and the other numbers have to stay the same. And I can't increase both the red from 3 to 4 and the yellow from 3 to 4. I'm only moving 1 ball. Okay. So to end up with 4s everywhere, I actually have to start off, well, could I lose a yellow? Would that work? Again, this doesn't work, because I can't increase my yellows now from 2 up to 4. That's too much. I can only add 1. But if I had on my first swap moving a green ball from bag A into bag B, so the number of green balls in bag A goes down by 1 and the other one stays the same, this is actually now possible to make them match. Okay, if I start with three yellows here and I add 1, I get up to 4. Adding in 1 yellow means the other numbers stay the same, so 4 balls here is still 4 balls here. N minus 1 green balls is still n minus 1 over here, and that has to be 4 to make sure that we have the same number of every single colour. That's what the question says, equal number of red, yellow and green. So in this scenario, the n minus 1 balls is 4, so n is 5. So starting off with 5 green balls, losing 1 of them into bag B, and then taking from bag B a yellow ball, and end up with 4 of every single colour. That's the first kind of possibility, first case that could happen. Okay, I am firstly losing a green ball, and then I am gaining a yellow ball. So what's the probability this would happen? Well, in this case, starting with 4 red, 3 yellow, 5 green, the chance of losing one of my greens would be 5 out of, well, 4 plus 3 plus 5 is 12. So 5 out of 12 balls of green. What's the probability of now gaining yellow? You have to remember the yellow balls are actually coming from bag B. Now bag B, I know it starts off with 5, 3 and 1 over here. But in this case, the first swap adds a green ball over. So bag B will now have 5, 3 and 2. So the chance of picking a green ball from this bunch, sorry, I'm picking a yellow ball, aren't I? I'm adding a yellow ball. So the chance of picking a yellow ball would be 3 out of, well, 5 plus 3 plus 2 is 10. And the chance of both of these things happening in a row, I would multiply them. That's how we calculate probabilities. So that gives you, well, 15 out of 120, which implies 2, 1 in 8. So this was when n was equal to 5. Okay, cool. That was not the only possibility. Let's go and figure out what else could happen. Well, maybe instead of ending on all 4s, there's a different number I could end on. You might think, well, maybe I could end on all 5s. Right? Is that possible? Well, it's not. I have to gain 1 red ball and 2 yellow balls. That's at least 3 different swaps, right? And I know I only get 2 swaps. That's not possible. Same thing happens with 2s everywhere here. I have to make at least 3 swaps here. Not going to work. I can end up with 3s everywhere, right? So this is only sort of 1 swap so far. So let's figure out what happens. Well, initially, I know I need to lose a red ball, right? I start with 4, I end up with 3. So the first swap, which is where I lose a ball, has to be my red. I lose a red, the other 2 stay the same. Next swap, I can't gain back my red and then I'm back on 4. That doesn't work. If I gain my yellow, then I end up 3 red and 4 yellow. That doesn't work. I have to gain a green. And because I have to end on 3 of every single colour, gaining that green has to land me on 3 green balls. So n plus 1 balls is 3. So n actually has to be 2. Right? I start with 2 green balls. I gain 1 and end up at 3. That all adds up. So in this case, 3 of them plus 1, n equals 2. So second case, this is when n equals 2. Here, my first swap from A to B was losing a red. Let's get that in there. I lost a red. And second swap, what did I gain? Well, I gained a green. Probability of losing a red here, well, was 4 out of, well, n was 2, right? I can add that in. 4 out of 4 plus 3 plus 2 is 9. Okay, 4 out of 9. Let's go down slightly. 4 out of 9. Bag B now, that's where I'm choosing my green ball from. Let's do this. I initially gained a red ball from A into B. Sorry, there we go. Gained a red ball, so now, instead of having 5 red, 3 yellow, 1 green, I have 6 red, 3 yellow, 1 green. So the chance of me now gaining a green ball from bag B into bag A is going to be 1 green out of, again, 10 total. Right there now. 1 green ball out of 10. 4 over 9 times 1 over 10 is 4 over 90, which implies 2 out of 45. And those are actually the only possibilities, right? You can convince yourself, starting with 4 red and 3 yellow, you can't possibly end up on all the same unless you're ending on every number being 3 or every number being 4. So to put your final answer, you just need to say, well, case 1, n could be 5, in which case p, the probability this actually happening, we calculated was 1 in 8. Or n could be 2, and p was 2 in 45. So the final answer over there. I hope this is helpful. I am literally making these videos for you guys doing your A-level now. So if you've got a question you want me to look at, or just a general topic, please let me know. Right, I really want to listen to you and what you need. But otherwise, yeah, hope it's helpful, and thank you.